Hello and welcome everybody. In this talk I'm going to discuss Fyne Storage Repository System. So who am I? I'm Charles. I'm a PhD student studying computer science at the University of South Carolina. My research focus is high performance, heterogeneous, reconfigurable, and embedded systems. I'm also an open source enthusiast when I'm not busy doing my PhD research. Fyne is one of the projects that I enjoy contributing to. And in particular, I wrote the original version of the storage repository system we're going to be discussing today. When I'm not busy with those things, I'm also an aspiring home chef. And if you'd like to know more about me, you can visit my personal website at the link in this slide. As a disclaimer, views and opinions expressed in this talk are my own, not those of the University of South Carolina, the engineering department, or anyone else. So to start off with, kind of what's the lay of the land here? So applications written in Fyne need to access data. Most of them wouldn't be very useful if they couldn't. Sometimes this data could be on disk, like a file that you might think about in a typical desktop application. But also sometimes on disk doesn't necessarily mean you can access it with os.open. One of the motivational reasons why we implemented storage repositories in the first place was because a lot of mobile file access is mediated by these special platform-specific, generally URI-driven things, like if, say, the user has shared a file with your application through their share menu. Or maybe it's part of some other application that's exposed through an OS-specific API, but not just as a normal file on disk. Also on a deeply embedded system, like, say, some kind of kiosk where everything is stored in some kind of read-only memory or something like that, it might be advantageous to be able to bundle all of the files that you need into a single archive, things like that. Additionally, right, your data that you're interested in could be somewhere else completely different. It could be on the web. It might be part of a cloud storage service like, Amazon S3 or Dropbox. It could also be in an archive file, like maybe a zip or a tarball, something like that. And we'd like to make it really easy for developers to work with data from all of these sources in a simple and consistent way when they're developing their applications. So our design goals when we set out to create the storage repository system, kind of the first one was to be able to support mobile platforms. That was kind of the initial impetus that put us down this road, and especially being able to handle things like shared files and stuff like that. But we also wanted to be able to support any kind of file-like device. So for example, maybe you have an HTTP or HTTPS server, a zip file. Amazon S3 was a motivational example we came up with. You could imagine lots of different data sources that are kind of hierarchical and have kind of nodes that you could read or write data to. We'd also like to be able to make this solution extensible so that we can support use cases that we didn't specifically think of in advance. We've tried to make the API very flexible so that we don't want to hem people in and prevent them from molding it to fit their needs. We'd also like to allow for backend specific optimizations. So for example, if you're using a move operation with, say, Amazon S3, rather than downloading all of the data to the client and then uploading it back to the server again in a different place, it might be faster to use some kind of specific, remove command that makes that happen on the remote that might be faster. And so we've tried to expose API endpoints in such a way that the developer can just use a generic implementation where maybe they are pulling all the data down and writing it back out, without preventing them from being able to use an optimized version if one is available. So the history, this kind of started in August of 2020. We initially were running into the trouble that we needed a way to have cross-platform directory listing support with our existing URI implementation. And as we implemented that, we kind of realized that the URI system that we had at the time wasn't really flexible enough to handle everything that might come up in the process of dealing with files and file-like data when writing any kind of application. So in December 2020, which was my winter break, until kind of the mid-January, we developed this proposal, and these are clickable links if you download a copy of the slides. And if you can't, this proposal is in the wiki for the Fyne GitHub repository, and the numbers here that are in blue are either issue or PR numbers for that, in case you're interested in following along at home. And so in that proposal, that kind of doubled as a beta test for the proposal process that we now use for all of our proposals. And there was a lot of discussion about what we should do and how we should do it. This kind of turned into one of those problems where as we kept coming up with different ideas for how to approach it, we realized, wait, no, actually there's this use case that we want to support that this model doesn't work with. And so we iterated for quite some time, but eventually we settled on a model that I think works really very well, and I think everyone was pretty satisfied with. So I started this work in a PR in December, which was PR number 1665, and then we also ended up having to do a second PR, which was 1768, which got merged into the develop branch in January of 2021. This was one of the biggest open source contributions I've ever been a part of. There was a lot of discussion and going back and forth with the core team and quite a bit of code as well. It was 116 commits, 305 comments, 15 printed pages worth of proposal, and 2.8 thousand lines of code. So let's start diving in a little bit deeper. How does Fyne handle I/O, which really means how does the storage repository system work? So we have this concept of a URI, which is the hydrated version of an RFC 3986 URI string. So it could be something like file://something.txt, or it could be http://example.com, something like that. And kind of in our model of the world, this represents a reference to a resource that's kind of namespaced by the protocol that's kind of stuck on the left-hand side of that URI. So we'd say, and that's handled by a repository. So, for example, right, a HTTP URI, we would say is a reference to something that's in the HTTP repository, which is this, monolithic blob that handles all URIs of that type. Now, and internally, it could delegate to, several different systems depending on the contents of the URI, but that's an implementation detail. So minimally, we have to know how to test the existence of a URI, and we have to know how to open a reader for it to read whatever data is referenced. Additional capabilities can be implemented a la carte by a repository, which we'll talk about in detail a few slides later. So for example, if the repository that you're working with allows for modifying data, there may be endpoints for obtaining a writer as well, or for creating a new empty file or something like that. So the repository object essentially tells Fyne how to work with URIs of a particular type. So, right, there may be some abstracted endpoint which is in the storage module that could be something like, open, right? It might get a reader. I actually don't think that API endpoint is called open. That's on a later slide. But what that actually does is, under the hood, it's just calling into the storage repository that's been registered to handle the file protocol. And you can register repositories at runtime. By default, you get the file one. That's kind of set up out of the box. And I think as of 2.1.0, I believe HTTP will be set up and registered out of the box. But you as the end developer, right, if some third party has developed a storage repository that you want to use, you can also pull that in at runtime, no problem. And so, yeah, like I said, calls to methods in storage internally, right? It's just checking that protocol that's in front of the URI and then delegating it to whatever appropriate repository has been registered to handle that. So how do we know which features a repository supports, right? Because, say, like a file, right, you could read that or you could write that, but maybe in HTTP you can only read, or maybe you have a read-only zip archive and you can only read stuff, you can't write stuff, or different things like that. Or maybe you're doing some crazy data model we didn't anticipate where getting directory listings doesn't make sense. So we do this using type assertions, actually. The code here I have on the right actually is taken right out of the storage repository code, or out of the storage module in particular. So this defines the process of getting a writer, and all we do is we say get the repository for this URI, which is just doing that lookup based on its protocol, right? So like file:// would be a file repository, and then we try to cast it to a writable repository, which is just an interface that defines certain extra methods above the baseline repository type. And if we fail to do that, then obviously this isn't a writable URI and we can't obtain a writer. So we return an error that indicates it's not supported. So for example, in this case, a writable repository, that interface means that you have to know how to get a writer, which returns a write closer, which you can use with all your standard IO util methods that you know and love. Can write, which is just intended as a performance optimization, because on some systems it may be faster to check if you can write to something rather than trying to do it and seeing if it fails. And then delete, which as opposed to just overwriting it with just an empty byte string, right? That actually kind of, in the context of a file system, for example, would remove that node from the file system. Now, whether or not delete's meaningful in the context of a specific repository's kind of implementation defined, but on a file system, right, delete does exactly what it says on the tin. So what repository interfaces are available right now? There will likely be more in the future as we see how the community utilizes these capabilities, but these are the initial ones that we've set up for kind of the first go around of getting repositories going. You've got your baseline one, just called repository. Everybody has to implement this minimally, and this provides your exist reader can read, right, which essentially checks for read permissions and destroy. Custom URI repository allows you to override the URI parsing routine. So if you have something that's not compliant with the RFC, which we know that some maybe vendor-specific APIs may not be, and so it can be useful to be able to do that yourself. Writable is for things you want to be able to mutate. Listable means that you can obtain something analogous to a directory listing. May not always be the case for every type of file storage backend. Hierarchical means specifically that you can get the parent of a URI, and also that you can create children, or at least attempt to create children of a URI. And you might go, well, aren't all URIs hierarchical? And yes, per the spec, but that's not necessarily true in terms of how people have actually implemented them, right? So if you have, some magical proprietary API, // a big base64 blob, that internally on some vendor's backend might mean something significant. We might not know how to create a parent or a child, or thinking about the parent or the child might be some other horrible base64 blob and not something that semantically equates to a parent or a child as we think about it, like with a file path, saying dot or / child name. Copyable repository allows you to implement copy. We have a generic version of that you can use if you don't want to implement an optimized version, and our generic one just reads all the data as a reader, obtains a writer, and writes it all back out. And movable is analogous. And all of these are available in storage /repository/repository.go in the main Fyne repository. And they're all commented and documented, so if you're interested in learning more information, you should give that a look. So what repositories are available right now? So currently all of our official repositories are in internal /repository, and specifically file and HTTP get added automatically to apps at startup. File was added in the initial version of storage repositories that released with 2.0.0. HTTPS support and HTTP support have recently been added in PR number 2239 and are going to come out with 2.1.0, which, barring any technical hangups, will probably already be out by the time you're listening to this talk. We've also got a mem : // We haven't made that available as a public API yet because it's not quite in a state that we're ready to commit to supporting it. But we use this internally to simulate a file system for a lot of our test cases, and I think we'd like to make something like that available as a public API in the future once it's more tested and more robust. And of course, more to come. And obviously the community, we hope, will also write some as well that may facilitate the projects or use cases that they're interested in. So why did we design storage repositories in this way? We wanted developers to be able to use just a single set of API endpoints in storage, not having to use interface methods, right? For example, we had originally thought, we'll just add this to the interface type, but then that now means that everyone that wants to implement a storage repository, which we hadn't really quite coined that term yet, now has to implement all of these interface methods on all of their URIs, and a lot of them are going to be redundant, copy-pasted, boilerplate, stuff like that. So that's kind of why we ditched that and decided to just make them be regular functions in storage where you give it a URI as the first argument. And we really want to make sure everything just works really smoothly for developers on the happy path. If you're just using a file dialog or something like that, in kind of the intended way, it should hopefully be really simple and straightforward and not have too many footguns. But we'd also like to make it so that if you want to do something that's not on the happy path, it's still possible, and we're not constraining you from being able to do that. Also, we want to make it so that a library or application that's using our storage API will also work automatically for free with future, as of yet unwritten storage repositories that we don't even know about yet. And the way we've designed it, you can do that. You'll be able to, if you write an application now, and next year somebody implements a Dropbox storage repository, your application will just work with those URIs for free, assuming it's been registered appropriately. Also, we can add new repository interfaces to expose new functionality, like maybe we wanted to have a get compressed reader or something that reads some kind of transparently compressed object. We could add that without breaking existing code or existing repository implementations, because that would be a new repository interface type with a different endpoint and storage and a different type assertion. So all of the existing code would still keep working, and library authors, especially repository implementers, wouldn't have to do any work in order to get their code working, or to have it continue working, I should say. So now let's take a look at a code example just to kind of maybe drive this home a little bit. So this is just a little simple application. It's going to pop up, let us enter in a URI, and then it's just going to read that URI as text and show it on the screen. So we're just going to drop all that in a label, and we'll create a little entry that the user can put their URI in. Now, of course, normally as a developer, you're not going to be creating something where the user is dealing with raw URIs. You'll be calling into something like the file picker or something like that. But for this simple example, it'll be fine. We got some error handling. This will be the callback that is called when we want to enter our URI. We show a little form that the user can type that URI into, and then this function here, starting on line 39, is kind of the real meat and potatoes. So first we get this, textual URI. Now, if you were getting this back from, say, the file picker, it would already be a hydrated URI and you wouldn't have to parse it. But since the user's entering a string here, we have to parse it because it might not be valid, right? So we do that, throw an error if it's bogus. Then we get a reader for it. Again, that could fail, right? If it's a non-existent file or you didn't have permission to read it or something like that, it could have a valid URI, but there might not be anything on the other end of that reference. So we try to obtain a reader, throw it away if we didn't get it. Finally, we just read all of it, and I do want to emphasize, right, we're just using ioutil.readall. So if you had code that was already using like ioutil or other Go packages that work with things like readers, all that'll still work pretty much in the same way. So we do that, and then we overwrite our main label with our text, which will mean it'll show up in the middle of the window. And then the rest of this is kind of your standard boilerplate that creates a menu, wires that menu up, makes the contents, take that main label and whack it in a little scroll container, resize the window, all that good stuff. And by the way, just for documentation purposes, this was written against Fyne 2.1.0 RC1. So I would reasonably expect it to still work against Fyne 2.1.0, barring some unforeseen technical snag. So now I'm going to switch over to a little video showing this code working. So here's our video. I'm going to hit play. So I go up there, enter my URI. This first file is just one that I created for this demo. It's just got some dummy text in it. And there you go. There's the contents of our plain text file. And then as another example, I'm going to enter in my personal website, which is going to be an HTTP URI. And we'll see that it'll pull that down. Of course, that's going to be raw HTML. But as we can see, it did in fact pull that data down. And ioutil.readall doesn't have to care. All right, let's switch back to our slides. All right, so wrapping up. The storage repository system allows Fyne to abstract access to any kind of file-like resources, which includes files. It now also, as of late, includes HTTP and HTTPS, and in the future, hopefully, will include much more. As those new repositories are added in the future, existing applications will basically get more functionality for free without having to do code changes, or at most, right, maybe pull in an extra dependency and register a repository. All Fyne APIs that deal with any kind of files already use storage repositories internally. They pass around URIs. So if you're kind of sticking on the happy path and using only the official APIs, all of this should kind of just work transparently with hopefully very little cognitive overhead. Additionally, new storage repositories can be loaded at runtime, which means that Fyne, including our internal APIs as well, but also third-party libraries, can access storage backends that their authors never accounted for, right? So if you write a storage backend that's specific to Google Drive, you can pass that to Fyne internal APIs as long as it's a URI and you've appropriately registered the repository, and they'll be just as happy to work with that as with a local file. All right, thanks for watching my talk.